All right, this review is going over the redox and acid-base reactions. First question, redox reactions involve the transfer of electrons. Elements that are oxidized, they lose electrons. They become more positive. And elements that are reduced gain electrons. They become more negative. Whenever you're gaining electrons, you're gaining more of a negative charge. Number 3, assign the oxidation numbers to all the elements in the compounds below. So manganese is a transition metal, which is in the middle. It's really hard to get that oxidation number. But for the rest of them, group 1 has a positive 1, group 2 has a positive 2, group 13 has a positive 3, 14 has a positive 4, or negative. Those are also tricky. We're going to have to work through those. And then we have group 15 with a negative 3, negative 2, negative 1, and the last group has a 0 charge. All right, so we know oxygen has a negative 2 charge because, again, it's placed in group 16 on the periodic table, so it has a negative 2. But there's 2 of them there. So that means it'll have a negative 2 times 2, which will be a negative 4. So manganese has to balance out with that. So manganese will have to be a positive 4 charge. So Mn would be a positive 4. That oxygen with the 2 would be a negative 2. All right, Au is gold. But since it's alone and it's by itself, it does not have a charge. Any element that's alone will not have a charge. All right, next we have Na2SiF6. So Na has a positive 1 charge. But there's 2 of them again, so we're going to have to multiply that by 2, so that'll be a positive 2 charge. F, fluorine, has a negative 1 charge. And there's 6 of them, so negative 1 times 6 would be a negative 6. Silicone is in that group 14. Those are the ones where we can't really justify if they're a positive or negative 4. We're going to assume that they act like transition metals as well. So we need something to add to our positive 2 to cancel out with the negative 6. And that's going to make silicone a positive 4. Because 4 plus 2 is 6, and that'll cancel out with that negative 6. So Na2 will have a positive 1 charge. Silicone will have a positive 4 charge. And F6 will have a negative 1 charge. D, we have Na3PO4. Na again has a plus 1 charge. There's 3 of them, so that'll be a positive 3. Oxygen, just like before, it had a negative 2 charge, but there's 4 of them, so that's a negative 8. So our phosphorus is going to have a charge that's going to cancel out with that negative 8. 8 minus 3 is a 5, so phosphorus will have to have a positive 5 charge. So that means my Na3 would be a positive 1, phosphorus would be a positive 5, and my oxygen would be a negative 2. Finally, sodium chloride right at the end. Sodium's positive 1, chlorine's negative 1. So Na would be a positive 1, Cl would be a negative 1. Again, gold is the only one that's 0 because it's alone. Any element that's alone, the charge will be 0. For the following reactions, determine which element was oxidized and which was reduced. In order to do that, first we need to figure out the oxidation charges. We have tin here on the left and sulfur. Sulfur on the periodic table has a -2 charge. There's 2 of them, so that's -4. So tin will need a +4 charge. Oxygen's alone, there's no other element with it, so the charge is 0. After the reaction, tin is now with oxygen, which has a -2, and there's 2 of them, so that's again a -4, so tin will need a +4. And then we have sulfur and oxygen with a -2. Oxygen has a -2 charge times 2, so that's a -4. So this sulfur will have to have a +4 charge. So the one that gets oxidized is the one that becomes more positive after the reaction, and that will have to be our sulfur. Sulfur before has a -4 charge, but after the reaction, it's going to have a +4. So sulfur gets oxidized. The one that gets reduced, oxygen before does not have a charge, and after the reaction, it has 2 negative charges. So oxygen is reduced. Next, B, we have aluminum by itself, that charge is 0. We have chlorine by itself, that charge is 0. Then we have aluminum with chlorine. Chlorine has a -1 charge, and there's 3 of them. So that'll be a -3 charge. So that means aluminum is a +3. After the reaction, which one's oxidized, which one becomes more positive? That would have to be aluminum. Before it's 0, after it's a +3. So aluminum is oxidized. Which one is reduced? That one will have to be chlorine because it's 0 before, -3 after. So chlorine is reduced. C, we have magnesium that's by itself, so that's a 0. Nitrogen by itself, that's a 0. Then we have Mg3 and 2. We have 2 nitrogens. Nitrogen has a -3 charge times 2, that'll be a -6. Magnesium has a +2 charge. There's 3 of them. That's a +6. Which one becomes oxidized, more positive? That's magnesium. And then which one becomes reduced? That's the nitrogen. And again, the reduced one becomes more negative. All right, let's do D. I have NH3. Hydrogen has a +1 charge. There's 3 of them. So that makes it a +3 charge. Nitrogen has a -3. We have Pb and O. O has a -2 charge, so that means lead has to have a +2. Nitrogen is by itself, so it has a 0 charge. Lead is by itself, so it has a 0 charge. And then after the reaction, we have our hydrogen with a +1, but there's 2 of them, so that's +2. And then we have oxygen with a -2. So which one is oxidized? Which one became more positive? Let's see. Hydrogen's still positive, but nitrogen went from a -3 to 0. So it's becoming more and more oxidized. So we're going to say nitrogen is oxidized. Which one became more reduced? We have lead with a +2 charge, and then it goes down to 0. So lead is getting reduced. Let's go to number 5. In the activity series, the reactivity of metals blank as you go down the series. As we're going down this chart, the reactivity of metals decreases. This means that metals can only replace other metals if they are more reactive, if they are higher on the list than the metal that's being replaced. Number 6, use the activity series to determine if the reaction will take place. If no reaction occurs, write no reaction. So for A, we have copper, and it's going to switch with zinc because that's the metal. Let's check on our list if copper is higher than zinc. So copper's down here, zinc's up here. So zinc is actually higher. So this one will have no reaction. All right, next we have copper, and it's going to switch places with silver if it's higher on the list than silver. Ag is silver. So let's check. Copper is actually higher than silver, so the reaction will occur. So Cu will now be with Cl, and Ag will be by itself. Let's do calcium now and zinc sulfate. So calcium and zinc, calcium is higher than zinc. So now calcium will be with sulfate and zinc will be alone. Checking our charges, sulfate has a -2 charge on the polyatomic ion list, and calcium also has a +2 charge. So those twos cancel out, so we don't need any other subscripts there. And the last one, we have zinc switching with magnesium if zinc is higher. So let's check our chart. Zinc is actually lower than magnesium, so this one will have no reaction. Number 7, for the reactions that did occur in number 6, write the reduction and oxidation half reactions. So we're going to write the oxidation and half reactions for these two. First, we need to figure out their charges to see which one's reduced and which one's oxidized. So I'm going to do B, Cu plus AgCl, CuCl plus Ag. Copper has a 0 charge because it's alone. Chlorine has a -1 charge, so that means silver will need a +1. After the reaction, chlorine has a -1, so copper will have a +1. And then silver has a 0 charge because it's alone. So the one that becomes reduced is the one that becomes more negative, and that will have to be silver. At the beginning, it's +1. After, it's 0. So silver has a +1 charge, and it needs to gain some electrons, so afterwards, silver has no charge. In order to get rid of that +1 charge, it needs 1 electron. All right, the one that gets oxidized is the one that becomes more positive, and that would have to be copper before it's 0, after it's a +1 charge. So for oxidation, copper has a 0 charge, so we have copper by itself. After the reaction, copper has a +1, and that means it gave away its 1 electron after the reaction. Let's do C now. C has calcium plus zinc 2SO4 yields CaSO4 plus zinc. Calcium is 0 because it's alone. Since sulfur has a -2 charge, that means zinc will have had to have a +1 because there's two of them. 1 times 2 would be a +2 to cancel that out. After the reaction, calcium has a -2 charge. Sulfate has a +2 charge. Oh, sorry, I said that backwards. And zinc now has a 0 because it's all alone. So which one became reduced? Which one became more negative? That's going to be zinc. Before it's a +1, after it's a 0 charge. So reduced would have to be zinc. There's two of them there, and they have a +1 charge. 1 times 2 is a +2. So that means it would have to gain 2 electrons to become zinc with no charge. And there's 2 zincs there. That should have been balanced. All right, oxidized. The one that became more positive should be calcium. Calcium before has no charge. After the reaction, we have a calcium with a +2 charge, which means it gained 2 electrons. All right, let's keep going. We're going to write the definitions for the following vocabulary words. An Arrhenius acid is a hydrogen containing chemical compound. And it increases the concentration of hydrogen ions. We can also call those hydronium ions, which are the H+. The Arrhenius base are bases that are hydroxide containing compounds. They increase the concentration of hydroxide ions, which hydroxide ions are OH negative. And then a Bronsted-Lowry acid is a proton donor. And a Bronsted-Lowry base is a proton acceptor. And we'll leave off here for this first part of the redox and acid-base reactions.